Good day and a very warm welcome on behalf of NTi-Audio. Today we are talking about the rating level of industrial or environmental noise, or in other words, we are talking about how to assess the annoyance of an environmental noise. But let me please first introduce myself. My name is Markus Becker. I'm moderating this webinar and I'm assisted today by Berno Niksch. He is an expert in rating level and all related issues, and he will respond to your questions during the presentation. The topics that we have prepared for today start with a brief view on the motivation, why we are talking about rating level and the scope of this webinar. Then we will explain in more detail the technical meaning behind the term rating level. We will give some basic information about the sound level acquisition. Then we will explain the tones and impulses that play a major role for the rating level assessment. We will also say some few words about timing issues. And then we have prepared a practical presentation for you. After that, I will summarize the key issues of my webinar before I will take a look at the questions that have popped in and provide some additional information. I expect that this webinar will last approximately half an hour. The question, why do we have to introduce rating level or this assessment of the annoyance of sound, is quite obvious. Typically, when we measure the sound level of environmental noise, of industrial noise, we are using the A-weighted LAeq. However, this term does by itself not consider the annoyance of a sound. You may have a certain LAeq which sounds quite acceptable, and you can have another environmental noise with the same LAeq, but that is highly annoying, highly disturbing. So what we need is a measure to rate this annoyance, or that is called the rating level. Just an important restriction. In this webinar, I'm focusing mainly on the calculation of the LR and only a little bit on the auxiliary issues, the other issues of this whole topic. So let us take a closer look on the definition of the rating level. It represents, as stated, the perceived annoyance of noise. So it is actually a combination of the sound level of the noise source plus some penalties that have to be applied depending on the content of this noise source. So in practice, it looks like that. We are measuring the LAeq as a fundamental value, and then we're adding these penalties. And the penalties represent the impulsiveness of that sound, the tonal components that are in that environmental sound. We have another penalty for the time of the day or of the night, and we have an adjustment for special situations and noise sources. So what does that mean? Here, the fundamental measurements are objective measurements, so they can be reproduced with any test system that complies to this standard. On the other side, this special adjustment is reserved for a subjective assessment, and that is very important, that the standards include the statement that you, as the acoustic expert, have to subjectively assess whether additional penalties have to be applied because there are some specifically annoying sound components that cannot be detected with these objective measurements. So here your experience as acoustic expert plays a major role for the overall assessment, for the overall result of the rating level calculation. When we talk about the acquisition of this environmental noise, we start, of course, with the measurement of that LAeq. We have to look for a representative location. We have to make sure that the microphone is positioned in the correct height and in the correct position. We have to note the weather conditions, especially the wind, because it may play a major role on the result of the measured LAeq. And then we have to prepare our test instrument correctly. We have to set the timing interval to 1 second, the logging interval. We should record the third octave spectra. Here, this depends a little bit also on the national standard. Some national standards only require the LEq, some others, in addition, the maximum and the minimum level of spectra. Then we should also record the audio data as a wave file and all the levels that the test instrument can record, because we will need these levels for these specific calculations of the tones and the impulses. Please refer always to the applicable standard in your country, or take a look at the help file of the Data Explorer software. In there are also some additional explanations for these settings. And then, after having recorded the sound level, we can start with the analyzation, the analysis, which means looking for the tones, for the impulses, and for other sounds. Well, when we talk about tones and impulses, why do we do it, and what exactly are we doing? Tones and impulses are usually the most frequent sources of annoyance. So if you have a loud, or let's say a background noise with some loud impulsive noise, then these impulses make the annoyance, for instance, and the same may apply for the tones. How can we detect the tones? First of all, we have to look in the frequency domain, which is quite obvious for the tone detection. Here I have plotted the FFT spectrum of a tone. Now, one approach is to split this frequency spectrum into third octave bands. These dotted lines represent the borders of the third octave bands. And then we can calculate the levels of per band, and we can identify whether one band stands out, which means that the difference between this band here with this apparent tone is higher than the levels of the adjacent third octave bands. And to say it very roughly, this is the so-called third octave band analysis. This is one approach to identify tones in the spectrum. A second approach comes from the fact that it may happen that this splitting into third octave bands results that our dominant tone is exactly on the border of two bands. So how can we detect this tone? Because if we would apply this method up here, we will hardly find this tone, or we would hardly be able to identify, to detect this tone. So here we need another approach. I will come back to the details of that a little bit later, but basically keep in mind this is the FFT-based analysis of tones. So we have a third octave-based analysis and a FFT analysis. On the other side, we are talking about impulses, and to detect them, we have to take a look at the time domain. Here we see a time plot of a sound. You can see here there are some peaks. Now, to identify whether these peaks are impulses, are annoying or not, we have to know the level difference, of course. But we should also take a look at the duration, because it could be that this is not an impulse, this is another kind of sound. So this is another parameter, the duration, that gives us an information whether we are talking about an impulse or not. And last but not least, also the number of impulses per the period while we are watching the whole situation plays a major role. Because if we have maybe just one impulse for one day, this might not be sufficient to say this is annoying sound. but if we have repeated impulses over the time, then we would come to the conclusion, yes, it is annoying. So let us take a look at the standards. How do they cope with these challenges, with the detection of tones and impulses? First of all, we take a look at the ISO 19996, and here we have the so-called survey method, and that is exactly what I showed you before. The survey method identifies third octave bands that are standing out from the spectrum, which means that the level difference to the adjacent band is clearly measurable, detectable. Actually, it must be higher than 15 dB in these low frequency bands, 8 dB in the mid range, and higher than 5 dB in the high frequency range. And if you detect such a band, such a tone, then you have to apply this penalty, this adjustment, depending on the amount of the difference, penalty of 3 to 6 dB. Then there is a second method, which is the FFT-based one. It's called the engineering method, and it calculates the difference, the level difference between the level of a prominent tone, the one we are looking for, and the level of the masking noise in the critical band around the tone frequency. I don't want to go too deep into these details. I'm going to show you just a sketch on the next slide, but just to keep in mind, it's not important that you understand the exact calculation, but that you know the engineering method is FFT based, and here again, depending on the amount of the difference, we have different penalties. Now when we take a look at the national standard, this is the British standard, the 4142, we have again the third octave method. It's basically the same as the survey method we just saw with the ISO standard. We have also a penalty of 6 dB in case that this condition is met. Or we have the so-called reference method. That would be the FFT-based method. And here on this sketch you see the instruction how to calculate this level, to make the decision whether there is a tone or not. I will certainly not bother you with the details of this calculation. It's quite demanding, as you can see, but in the end, if you apply this correctly, you will also get a statement for the adjustment or the penalty of this tone here in the FFT spectrum. Let's go to the second part, to the impulsivity, so detection of impulses. Now there's something interesting because the ISO 1996 states that there is no international standard to detect impulsive sound. However, there are some national standards like the British standard that has such a definition. So here you can see the so-called onset of a sound plays a major role. The onset is important regarding the positive slope, must be very steep, must be higher than 10 dB per second. The prominence plays a role. So again, it's a little bit complex calculation which we don't have to fully understand. But what is important, you have to know that you have to apply this measurement. You need a measurement system that can do this analysis in order to detect the impulses according to the standard and to correctly calculate the corresponding penalty that results from a detected impulse. There are some other methods just to mention. Some of them refer to the difference levels. So we are measuring the impulse weighted EQ over a short time, for instance, per second, and we distract from that the averaged level to identify impulses. So here these are all very similar methods. We have an Italian method, an Italian standard that again calculates the difference between these between two levels, a short-term and a long-term average. It also says something about the decay, so the impulse must be shorter than 1 second. we have a minimum number of such impulses that must occur to be rated as annoying, and here we have again the corresponding penalty. So just to give you this idea, please make yourself acquainted with the requirements in your country to make sure that you are calculating the impulses correctly. Well, this slide refers to the measurement duration and the periods. I've listed 3 standards, the British standard, the German, and the international one. You can see they have different requirements regarding the minimum recording duration, 1 hour for minimum 30 minutes. The German one splits the day in different slots of different importance. It even applies some additional penalties for the most sensitive parts of the day. The night time is handled differently to the daytime, and so on and so forth. So just to give you an idea that here again the standards play an important role on what you have to do. What is really important for you when you record a level for a rating level analysis, you must also record the real-time data to be able to prove when an incident has happened, and tone and impulse, whatever, so that you can rate it properly. I'm at the point of my practical presentation. I have here on my PC the software running, the Data Explorer software. I have uploaded recording data from my XL2, and I also have a loudspeaker connected to the PC so that you can listen to some of the parts of that recording. I'm going to switch over now to that software. You can see that here. And you see the recording was quite short, was just 3 minutes. The red line is the short-term level. The blue one is the LAeq. You see below the spectrum of the overall recording, and if I move the cursor, you see the corresponding spectra of at the corresponding point. Up here, the blue bar represents the audio recording. I'm going to show you just in a minute how I can use that. Well, the first step I would do is to identify the tones that have occurred during these 3 minutes. And for that purpose, I open the automated marker generation. I select pure tone. I select the appropriate standard. In this case, I take the ISO standard. I define the minimum duration of a tone, 3 seconds. And here I select the marker type I want to use. I want to assign the parts of the recording that comply to the standard with the marker type tone. So I say calculate. It finds markers. I confirm. And here you can see them now. Now, at this point comes your job, and that means you have to verify whether these automated generated markers are correct, or in other words, whether behind these markers stands really a tone. I give you just one example here. In that part, you see here, if you look at the spectrum, you can see there is apparently 1 third octave band that is standing out from the others. But if you look at the sound level recording, it does not really look as if there would be a loud noise. So for that reason, I'm going to replay now that signal, and maybe you can hear it, and you're going to see whether some tone is happening in that part or not. Maybe you heard it, there was no tone present, so apparently the system identified this marker, but it's not really a tone as we would rate it, and for that reason I delete this marker. Now I have done that already for, I know the result here of my recording. I'm gonna edit these markers now accordingly. This, for instance, is not a tone, it's an impulse, so for that reason I delete it. Here the same. Here I have a tone again. This one is a little bit too wide, so I have to edit it. So, and this one again is not a tone. Yeah, so these 7 markers would remain, and they actually stand for a tone. I can also prove that by just listening to one of them. I hope you could hear it. It's a high frequency tone that was present at this time. Now the next step is to identify the impulses. I again open the automated marker generation. I select impulsive sound. This is the most commonly used approach to find impulses. And now I assign the result to the marker type impulse. Calculate, confirm, and here you see the impulses that the system has found. However, same as with the tones, we have some not correct identifications. So I'm going to delete them. This is one. This is not. There's neither. Sometimes a negative slope as identified as an impulse, which is not correct. But these are again impulses. Here we have an impulse. And yeah, that's what I would like to let it stand. Now, the last step I take is, and this is also part of your duty, when you listen to the recording, you may identify tones like this part here, which is apparently present. It is neither a tone nor an impulse, but it is annoying. And for that reason, we have to mark it as a special event. I do that manually. That's it. So 3 types of markers, and now I can start the calculation of the rating level. For that purpose, I select here the corresponding button, rating level. This pop-up window opens. Up here you see the timing. You can edit that if you want. You can split, for instance, the day in slices of 1 hour if you want here, as it is. You see 60 minutes. I could also say, no, I want just confirm. And here I have now the penalties for the corresponding markers. I just have one penalty for the tone marker, so I need to add the penalties for the other 2 types, for the impulse markers. Let's say we have a 6 dB penalty for impulses. And in addition, our special marker, which let's say has a penalty of 4 dB. I confirm. Now you can see them, 3 markers that are important for our calculation, the corresponding penalties. Furthermore, I want to count the number of impulses that have occurred, and I let the system calculate the result. So you see 2 lines. And why do you do that? Because if we go back to our recording, you see here I started briefly before 10 o'clock, and so the 10 o'clock point was just the moment when the recording was virtually split, because here I have the 60 minutes time interval for this period. So we have a first part, 1 minute 20, up to the moment of the 10 o'clock time, and then the 1:40 afterwards. So for the first part, I have an LAeq of 91.8. The total penalty of all markers is 3, and that gives me the rating level here for this first part of 94.8. And the same for the second part of my recording from 10 o'clock onwards. Here the LAeq is a little bit higher, same penalty, so the rating level is of course also higher, because 93.1 plus 3 gives 96.1. Furthermore, I have 1 impulse count marker in the first part and 2 in the second one. So this information is the one I'm looking for. Just another hint, you can, when you right-click here in the RTA, you can also show the tones. You see here these black bars, they give us the feedback, depending where the cursor is positioned, of the tones that the system has detected. So those 3rd octave bands that are standing out enough to meet the condition, the requirement of the standard. If I move the cursor out of the chart view, you see here, this is the overall the spectrum of the overall recording with the corresponding tones. Now remember, we had also the FFT-based tone analysis, which is an alternative to the third octave band analysis. And this is done in this way. We right-click here on the audio bar and we select FFT and tone analysis. So here I just have to select the standard. I go for the ISO 1996 again, and I confirm and say calculate. So the system takes a couple of seconds to calculate the result. Here you see it. Here we have the tones that have been detected during our recording period. The 5000 Hertz tone apparently was the most prominent one. The audibility is the highest one, and it gives us a full penalty of 6 dB. Here, down here, you see the FFT spectrum of the recording. We can also zoom in into a certain part in order to analyze or to take a closer look at certain parts of the spectrum. And yeah. The other thing is that now you want maybe to export this data. You need it for your documentation or for further calculation. So you can click on this Export to Excel button. You select the file where it shall be saved, and then you will see the result here in this Excel sheet. You see we have the ISO 1996 analysis of this sound file that has been acquired with this instrument. Down here we see again the frequencies of the tones that we have detected with the audibility and the penalty, plus addition some further information that might be interesting for you. So just to wrap that up, if you calculate the rating level based on the FFT analysis of tones, you need to, let's get back here to our software. We need to disable this tone because that's a third octave tone. We can leave the impulse and the special penalty, but then we have to manually add the penalty that we have just found in the FFT analysis. We have to add that to the overall penalty here that the system gives us. Well, let me get back to my presentation and summarize the procedure. We start with the recording of the sound pressure level, the LAeq. In addition, we recommend to log all the sound levels that might be used for these post-processing calculations. We strongly recommend to, of course, we have to log also the third octave spectra for the tone analysis and the audio file for the FFT analysis as an alternative. Then you should detect or look for obsolete sound events. Let's assume, for instance, you have to monitor a construction site, and then all of a sudden a loud car accident happens, which has nothing to do with the noise from the construction site. So you have to exclude this car accident sound by deleting it or by disabling it in your chart view, and just to make sure that it is not that it doesn't have any impact on the overall calculation because it's not related to your task. Then identify the relevant tones and impulses and apply the appropriate penalties, together, of course, with these special tones that you have to identify manually and that you also have to rate manually based on your experience. Also, the daytime plays a certain role depending on the standard, and then you get the overall rating level, the LAeq, plus these various penalties. Well, I'm at the end of my presentation. I want to thank you at this point very much for your interest. I hope I was able to answer at least the majority of your questions, and of course I would be happy to welcome you at one of our future webinars again. For today, thank you very much for your attention and your interest. Have a good day. Bye-bye.